Hello students, welcome to the course Network Theory. In the previous video, we explained you about the maximum power transfer theorem. So there are three different statements and the three different statements have been proved. Okay. So now for these three statements, we'll try to see each one of the problems will be asked. Okay. So before that, just we recall what is the three statements. In any linear bilateral network, maximum power is transferred from source to the load when the load resistance is equal to the source resistance. Okay, so both the source and load, when they are resistance, so RL is equal to RS whole square. Okay. Second one, the load resistance is equal to the magnitude of the source impedance. If the source side, circuit A side, you have the equivalent impedance and you have the load resistance, then RL is equal to magnitude of ZS. Okay, so that is the second statement. Third statement, it is the load impedance is the complex conjugate of the source impedance. If both the circuit A as well as load has impedance, okay, then the load source impedance ZL is a complex conjugate of ZS. Okay, so these are the three statements. So each one case, so we'll see one problem. So most of the time the third statement they will ask the proof. Okay, and these two they will ask the problem. Okay, so it may change also. This can any theorem they can ask, anywhere they can ask the question. Okay, we'll see one problem on each so that you can able to do any problem is given. Okay, note down the first question. So this is a completely resistive network. In the circuit shown in figure, find the value of RL for which maximum power is delivered. Also find the maximum power that is delivered to the load. So this is the question asked in maximum power transfer theorem. First thing is you need to find the RL. Second thing, at that RL, what is the maximum power delivered to the load. Okay. So note down this network. So 120 ohm, 50 ohm, 10 ohm, 20 ohm, 8 ohm and RL, and there is a 20 ohm source, current source connected here. Okay. So note down this. So okay. So in such cases, so what we have told is in the very first yesterday told. Okay. So this we consider it as circuit B. Okay, as we have done in Thevenin's theorem. So this we'll consider as circuit B and we'll remove it first. Okay. So this is the circuit B. And whatever you have here, so we may name it terminals here. Okay, it is not given in this. So we call this as open terminals. Maybe you can name it A and B. Okay. And this side I call it as the circuit A. And you know Thevenin's theorem. So apply the Thevenin's theorem and find the Thevenin's equivalent voltage and resistance. That is Thevenin's equivalent circuit. We will find it for this circuit, VTH into RTH. Okay. So once that is done, so then you can easily find RL is equal to RTH and then use the formula power is equal to IL square into RL. Okay. So using that we'll calculate. Very simple. So just we'll proceed. Okay. So note down this again once again. So load is removed and we have told it is VTH now. Okay, so this is the thing. Okay, so this is how it is shown here. I1 current flows in this. Okay, so because of in between there is a current source is there 20 amps. So this loop we call it as I1 current and this loop we call it as I2 current. Okay, so that means to this current source these two are in parallel. Okay, because there is no current here, so this is omitted. So only this and this are in parallel. That is 20 ohm in series with 50 ohm, 10 and 20 ohm in series with 10 ohm. Okay, and these two are in parallel. So you can use the current divider rule to find the current in this. So if you know this current, we need to find VTH, right? So we need to find the current in this branch I1, current in this branch I2. We can apply the KVL and find out. That is the idea. So using the principle of current division, I1, that is this current. Okay, upper loop current I1 is equal to total current I into opposite branch resistance. That is this branch resistance we are considering R2 divided by R1 plus R2. Okay, so just substitute here. 20 is the total current. Okay, then R2 is opposite. So since it is open terminal, so these are comes in series now. Okay, so 20 plus 50 70. Okay, so maybe it is 170. Okay, so it is 120. Okay, so that's why 120 plus 50 170. Okay, so note down it as 120 and then 170 plus 30, that is 20 plus 30 total resistance. So it will give you So this is 220 by 20, 10 times 10, 17 times. So by orally you can calculate I1 is equal to 17 amps. Simple. Okay, similar way you find the I2 current, I2 in this branch. So which is 20 into opposite branch, which is 30 divided by 170 plus 30. Okay, so the same way you need to calculate. So you will get 3 amps. Okay, so just we'll see that. See here, I into R1 plus R2, 20 into 30 by 170 plus 30. So do the calculation. So 20, 10 times the 10, 3 times the. So I2 is equal to 3 amps. So now we'll apply the KVL clockwise to the loop comprising of the 50 ohm resistance, 10 ohm, 8 ohm and AB. Okay, so AB means it is VTH is there here. Okay, so what we get here is, so here minus to plus is there. So current direction is upward. Just to show you. So here this is current is entering here, right? So that's why this comes here plus minus. Okay, and this is downwards. So here it will come plus minus. Okay, so here there is no current, so this will be 0 and this is plus minus. So if you apply the KVL here, so or else you can take a new current here. Okay, so new current direction you can take. Okay, so you can take plus minus here. So then if you write, so you'll get the KVL. So it is 50 I2. Okay, so plus term I have taken, so plus 50 I2, then it is opposite branch resistance, no? So that's why 10 I1. So it is anyhow 0. Okay, and then plus minus VTH is there. Okay, so plus to minus notation I have taken plus in this case. Okay, so this is opposite to this I2, no? That's why minus 10 I1, and these two are in coincidence. Okay, so now VTH is equal to, so substitute I1 and I2 current, what we have done, 50 into 3 minus 10 into 17 plus VTH equal to 0. VTH, if you take this current that side, so what you will get, that is 170. 117 into 10 is 170. It will become plus, and this plus becomes minus. 50 into 3, it is 150, right? So you can write one more step, okay, if you are not following. So VTH as it is equal to, and these two terms taken that side, 170 minus 150, it is 20 volt. Okay, so this is the VTH. So now to find RTH, what we have to do, we have to deactivate the independent sources. This is the first case, right? Simple. So to find RTH, we have to deactivate all the independent sources. This results in a circuit diagram as shown. Okay, so the current source is open circuited here. So instead of showing that open circuit like this, so it is removed. That branch is removed because no use, right? So it is just a wire, right? So this is how the open circuit. And so now what comes the picture? So these two are in series, and these two are in these two are in series, 20 and 120, and this 10 and 50 are in series, and these two branches are in parallel, and this parallel is in series with 8 ohm. Okay, so that is equivalently written like this, 8 ohm as it is. Here these two are added. Okay, 20 ohm plus 120 ohm, which is 140 ohm written here, and here 10 and 50 ohm, which is 60 ohm written here. Okay, so then find the parallel connection, 140 parallel 60 plus 8. Okay, so you'll get the RTH. So see here, 140 in parallel with 60 plus 8, so 140 into 60 by 140 plus 60. So do this calculation, so how much you will get, 200. So 200 means, so both zeros will cancel, 2 3s are 14, 3s are 42, it will come. Okay, so this calculation you can do the, use the calculator also. 42 plus 8, 50 ohm. Okay, so this is the RTH. Okay, so this statement you have to write because it is a maximum power transform. For maximum power transform, according to the first statement, RL is equal to source resistance. So here source resistance is, we have calculated equivalent, that's why it is RTH, which is 50 equal to 50 ohm. Just if you write like this and straight away go to power, you will lose 1 marks here. Okay, so that's why this statement you have to write for maximum power. That's what they asked, right? Load resistance, which is equal to RTH, and then you have to write 50 ohm. Okay, so this is very important. Okay, so you can put the star here. Okay, why it is. Then maximum power you have to do the calculation. So the Thevenin's equivalent circuit with load resistor RL is as shown. Okay, for that we need to calculate current here. So that's why 20 volt VTH, 50 ohm RTH, and the load resistance is also 50 ohm. Okay, so now you calculate the current I, which is nothing but 20 by 50 plus 50, 100. Right, so that is the current you will get, and then multiply with RL, I square into RL you make, so you'll get the power. Okay, so just we'll do that calculation. So I is equal to 20 by 50 plus 50, 100, right? So it is 0.2 amps. 20 by 100 is 0.2 amps. So now 0.2 square you will make to find the P max. So this formula you can use here doing the this one, or you can take the ETH square by 4 RL. Okay, even this formula also you can take ETH square by 4 RL. Okay, so this also you can use to calculate the power. Okay, so P max. So this straight away you can use I into R. Okay, 0.2 square into 50 you will get 2 watt power. Okay, so unit is the watt. Hope it is clear. So this is the kind of problem so you'll have in maximum power transfer. Okay, so here Thevenin's theorem is required. So Thevenin's theorem or Norton's equivalent. Thevenin's theorem is the equivalent circuit. Then that we equate to RL, and then we'll find the I and the power. Okay, so this is the step. So now we'll consider source side complex circuit. Okay, so ZS, and we'll have the load as it is. Okay, so note down the question. For the circuit shown in figure, find the value of ZL for which maximum power transfer occurs. Also find maximum power. Okay, so rarely here problems are asked. Okay, so Thevenin's, Norton's, superposition, they will ask lots of problems. So maximum power transfer, that's why I take an important question which is asked in exams only. Okay, so this is the question we have. So 50 at an angle 0 degree volt means 50 only. 2 ohm, then J4 ohm. This is the load resistance they have shown with AB terminals, and then this is 2 at an angle minus 90 degree amp, which is in parallel with 4 ohm, and this is minus J4 ohm. So this they have shown RL means for finding Thevenin's equivalent circuit, you need to remove this circuit and you have to find the VTH across this. Okay, like plus or minus VTH you need to find. Okay, that is the idea. So note down this circuit, we'll see the solution. So here now J4 minus J4, these terms are there, and current is also all is in complex. So you have to consider it as ZS now. Okay, and this is RL. So first step is you convert this current source in parallel with resistance into a voltage source in series. Okay, so voltage source I into R. So you multiply this in calculator. Okay, in complex degree mode, 2 at an angle minus 90 degree you multiply with 4. So you will get the voltage magnitude and angle, and resistance value will not change. So it will be kept series with 4 ohm value. Okay, that is the first step you have to do. And then you have to do VTH. So to find VTH, so what you require here is here only voltage source is there, and since there is no open circuit, so there is no current in 4 ohm as well as minus J4 ohm, it is 0. Okay, so only you have the voltage source which is equated here, that will be there, and the J4 ohm voltage. Okay, so which is the current. So first we need to find the current in this branch, so that if you multiply with J4 it will become this voltage, and this voltage that will equate to VTH. Simple. So we'll do that calculation. Note down this. So disconnecting the load resistor RL from the original circuit results in a circuit diagram as shown below, and the current source is converted into a voltage source, and the circuit is rewritten as shown. Okay, so this is like this. So this is the nothing but this is minus plus. Okay, so this is minus plus now, 4 ohm, J4 ohm. Okay, so all these things are there. This is open now. Okay, as I told you, this is open, and this is, you can name it as plus minus. Okay, so you can write the KVL here. So here you have plus minus. Okay, any direction you can take. Okay, so like this also, like this also. So voltage direction is this side, so you can take like that only. So you can start from where you are starting, from there only you have to write. So minus plus is there, so which is 8 at an angle minus 90 degree. So this is the voltage source, right? So it is no need to multiply with anything, voltage source. Then 4 and minus J4 in series, and there is no current in this branch, it is 0 amps. Okay, that's why I will not write that part, it is 0. Okay, so you can write plus or minus 0, and then you have minus to plus. Okay, J4 ohm. So this is J4 into I, and then you have plus minus again. Okay, so it is minus VTH, or you can equate it to VTH. Okay, so now VTH is nothing but J4I, that is the voltage in this circuit, and this voltage. Okay, so you do this calculation, you'll get the VTH. Okay, but here I is unknown, so that for that you have to apply the KVL to this loop first. Okay, so what you have in this loop is very simple. A voltage source is there, and 2 ohm and J4 ohm is in series. Okay, so straight away you can consider this. Okay, so current I is equal to 50 at an angle 0 degree, nothing but 50 plus 0 I it will come, and this is 2 plus J4. So use the calculator and you will get the current. You multiply here, so you can use the calculator here. Okay, note down that equations whatever I done. Okay, so once again we'll have here, since circuit is not, I have to reference back, that's why I have shown there. Okay, I is 50 divided by 2 plus J4, so it will come 11.181 at an angle minus 63.44. Okay, you can write this in this mode, or you can show it in this. First it will give you this answer 5 minus 10J. First answer will be this, then if you do R at an angle theta, shift plus, you will get this answer. Okay, so this easily you can multiply. So because this is the first result, it will come in calculators, you can refer in next calculation this results. Okay, both you can write. Then applying KVL to the second loop, VTH is equal to J4 into this current, that's what I told you there, no, and this voltage 8 at an angle minus 90 degree. Okay, so this again, when you do the calculation, so it will give it in J form, 40 plus 12J I got. Okay, 40 plus 12J volt, and this is amps, that is written there. Okay, because this is not the final calculation, we will keep the final calculation in this one. Okay, so this VTH, if you convert this in R at an angle theta VTH, so it will come 41.76 at an angle 16.7 degree volt. Note down this. Okay, this you note down because VTH is the final one in one of the case. Okay, so we'll find similarly RTH now. So to find ZTH, what we will do, deactivate all the independent sources. You had two voltage sources, right? Here one voltage source and here one. So both are short circuited here. So it is short circuited, here also short circuited. So now look at the circuit, how these resistances are connected. So across these terminals you have to see. So these things you have to keep in mind. Okay. So if you look at the circuit now, so A side, so 2 ohm and J4 are ohm in parallel now. Okay. Now it is not in series, it is now parallel with respect to these terminals. Okay, so with respect to applying KVL here, it was series that time. Okay, now with respect to A, we need to find the resistance AB. So this side, if you see 2 ohm and J4 are in parallel, and this parallel connection is in series with 4 minus J4. Okay, that's why it is written like this, 4 minus J4 plus 2 parallel with J4. So 2 into J4 by 2 plus J4 calculated. So use the calculator, it will come 5.6 minus 3.2 I ohm. 3.2 I it will come. J you write in notebook. Okay, fine. So now we'll have the Thevenin's equivalent circuit. So before that, okay. So Thevenin's equivalent circuit with load resistance is shown now, and RL. So we need to find the RL and IL and P, right? For that RL, what is the case of RL in this case? If the source is having impedance, it is the magnitude of this. Okay, so magnitude will be calculated manually from like this. RL receives maximum power when RL is equal to ZTH. Okay, magnitude of ZTH. You can manually do this calculation. Okay, A square plus B square, 5.6 square plus 3.2 square. Or else what you can do, if you have this already the answer there, just to make R at an angle theta and note on only R part. Okay, so this is there no normally. Second part you will get the angle no need to note down, just note down the R value, first value it will come. So it will be 6.44 something it will come. So you equate it to 6.45 ohm. Even you can use this calculation, 5.6 whole square plus 3.2 whole square, and then take the square root. Also you'll get answer, whichever is convenient, because this you have done previously this calculation. Now just if you press shift R at an angle theta, so R you note down, that is 6.45 ohm. So this is the RL value. Okay, so this is the thing very important, I told you, don't miss this. Okay, that is what the theorem is about. Okay, RL receives maximum power, RL is equal to magnitude of ZTH. Why? Because it is a complex number now. Clear? So this is also over. Now we will calculate the power as it is. So this RL will be multiplied with the current IL. Okay, IL also magnitude we will consider, not the angle part. So little overwriting is there, so just follow with me. Okay, we'll explain you this. Maximum power is IL square into RL, the magnitude of IL square into RL. For that IL we have to calculate. IL is so Thevenin's equivalent voltage, okay, which is VTH. You can write it in J form. J form also you have, that also you can write, or you can write the angle form. 40 minus 12J something was there, no, 40 plus 12J. So write down that, okay, in the numerator, divided by resistance. What you had, 5.6 minus 3.2J as ZTH plus RL. Okay, so add this 5.6 and these are real parts, so add this and minus. So you take the ratio in the calculator itself in complex mode. 40 plus 12J divided by 5.6 minus 32J plus 6.45. Use the calculator. So it will give you the answer 2.85 plus 1.75J. This is the answer in J form. First 2.85 plus 1.75 J it will come. When you convert this into angle form, you will get 3.35 at an angle 31.57 degree amps. So this magnitude we want, no, that is the magnitude here, 3.35. Only that we can note down for power. So P max is now this IL square into RL. So IL square, magnitude of IL is 3.35. Take it square, multiply with RL. So note down the value. So you'll get 72.4 watts. This is the power. Okay. So hope it is clear, the steps. Okay, just you can repeat if you want. Okay, so whatever I have noted down also it is clear to you. This is the one part and this is the answer, and this is converted part of current IL. Okay, and here it is PL, P max. Okay, P max equal to IL square into RL. So this is the P max. Okay. Okay, so hope it is clear, the both problems. Okay, so you'll see the last variety. So these two are asked in exam. Third one is I am doing it because if both are comes, okay, then how you should take the, okay, so just I will go in speed so you catch up with that. Okay, note down the question. For the circuit shown in figure A, what is the value of ZL that will absorb the maximum power? What is the value of maximum power? Okay, so ZL and PL you have to calculate. So question, 120 at an angle 0 degree volt current, so voltage source 10 ohm in series with J15 ohm, and then you have a minus J10 ohm and ZL. So source side also you have ZS and here you have ZL. Okay, some load it is shown. Okay, no need to calculate. You have to calculate this value and you have to calculate the power. So how you calculate this? So now ZL is equal to complex conjugate of ZS. Okay, whatever value you'll get here equivalent. So the step is first, so remove this terminal AB. Okay, open these terminals and find the VTH here. Okay, then ZTH you file, then you equate it to this with a complex conjugate and then calculate. Same method. Okay, so just to show you the three variants of maximum power transfer theorem. So disconnecting ZL from the original circuit, we get the circuit as shown in figure. So this is the circuit looks. So what we need to find VTH, that means the current through this branch, right? So no, nothing is there here. VTH is equal to minus J10 into I. For that we want the current I. So for that you have to apply KVL here. Okay. So again here, so you can take this as plus minus. So 120 at an angle 0 degree minus 10 plus J15 and minus J10. So all this you can add and write. Okay, so you'll get I is equal to 120 by 0 volt divided by 10, and this is J15 minus J10. So straight away J5 it will come, 10 plus J5 it will come. So take the ratio in calculator, you will get the VTH. Simple. Sorry, I you will get, then you have to multiply with J10. 120 and 0 degree minus 10 plus J15I minus of minus J10I equal to 0. Okay, so sorry, I told something correct. Okay, so now I is equal to 120 at an angle 0 degree divided by 10 plus J15. So this current part is I have taken right side. Okay, or interchanged it. So 10 plus J15 plus part will come, this also become plus, and here you have the minus J10. So this will come, it is written as it is. So now VTH is straight away written minus J10 into this value. This value is 10 plus J5, right? So now together you can do it in calculator. So it will come 107.33 at an angle 116.57 degree volt. So this is the answer. Even you can have its complex conjugate form. So that is if you do that also it will show there. Okay, so just for your sake, so 120 into minus 10i, I'm doing it here, so you do that, divided by 10 plus 5i. So it will come minus 48 minus 96i. Okay, and then if you click shift r at an angle theta, so you'll get 107.33 at an angle minus 116.565 something it will come. Okay, minus 48 minus 96i, both are minus. Okay, so that is the answer it will come here. Okay, minus 48 minus 96j. So this is the answer you'll get in terms of complex form. When you convert this, it will come 57. I have written it will come 565 degree volt. Hope it is clear. Okay, as we have done two problems, so you can now able to do it. Okay, the basic is your KVL and KCL. Okay, so mesh analysis and node analysis. Okay, that is should be strong. Okay. To find ZTH, deactivate the independent voltage source as shown in figure. Only one independent source is there, that is removed. So then it will be short circuited. So now how it looks from A and B. So these two are in series, 10 ohm and J15 are in series, and this series is in parallel with J10 by just looking at the observation. Okay. So that's why it written here 10 plus J15 in series added, and it is parallel connection is shown minus J10. So R1 R2 by R1 plus R2, the same step. Okay. So minus J10 into, so because R1 R2 I can, why it can say, because it is in the J form, all are in the ohms form. Okay, not in Henry or Farad form. Okay, all are in ohms form, that's why it is impedance. Okay, so minus J10 into 10 plus J15. Okay, divided by minus J10 plus 10 plus J15. Okay, so you do this calculation in the calculator, it will come 8 minus J4. I have kept this in this form because complex conjugate I can take it easily. Okay, even magnitude also we can do it easily, that's why we'll write this in form ZTH. Okay, I got 8 minus J14 ohm, you verify. Okay, so this is the very important step. Okay, the third statement of the maximum power transfer theorem also proved here with this example. The value of ZL in this case for maximum power absorbed is ZL equal to complex conjugate of ZTH. Okay, in general I have taken their source. Now source is equated, no, as a equivalent impedance value only. So it was 8 minus J4 there. Complex conjugate is 8 plus J14. Okay, so this is complex conjugate. So now Thevenin's equivalent circuit along with ZL is shown here. So ZL we have removed earlier. Now we have connected with a value. Okay. So this is 8 minus J14 and this is 8 plus J14. And here you have the voltage. Okay. Whatever we have calculated here, 116.565 degree volt. So now this we take the I here. Okay, I is this voltage divided by 8 minus J14 plus 8 plus J14. J14 cancel out. 8 plus 8, 16 will come. So this value divided by 16 you will get I, and then take the square of that and multiply with this ZL. You will get the power. That is the last step. Okay, so hope you are noting down each and every step. Okay, I will proceed. You pause the video and note down. Okay, so this is the calculation I told you. This is the VTH, okay, voltage, and then resistor. Okay, one is complex conjugate, right? So J14 and J14 will cancel out. So 107 by 33 by 16 at an angle minus 116.57 I have written. If you are writing 565, continue that only. 565. So the maximum power is the magnitude of I square into RL. Okay, so magnitude part we want, that means we will take only this one. Only this we will consider. That's why this 107.33 by 16 square is written into 8. So when you do this calculation, you may get 359 or something. Okay, so I will equate it to 360. So 360 watt is the power. Okay, so this is the problem on maximum power transfer theorem. Okay, so with this we are completing maximum power transfer theorem concept as well as the module 2 network theorems also. Okay, so just to summarize, we have learned superposition theorem, We have learned Millman's theorem, then Thevenin's theorem, Norton's theorem, and maximum power transfer theorem. Okay, so the basic for solving this is the theorem statement. Okay, how theorem is applied, and next thing comes how you apply KVL, KCL, voltage division rule, current division rule. Okay, series, parallel connection. Okay, so all these are basic. So that's why basic concepts of network only I started off with. Okay, then we taken module 1. There we have considered source transformation, star delta transformation, then the mesh analysis and node analysis in detail for AC, DC, all kinds of networks. Okay, that's why module 1 took much of the time. Okay, so now we have completed the module 2. So next we have the module 3, 4, 5. So I start with module 5 first. Okay, and then I will come back to module 3 and 4. Okay, so with this I will end the session here. So go through all the things, revise it, note down your doubts. Okay, we'll conduct a session, okay, to solve the doubts, okay, as you complete, and we can proceed like that. Okay, so thank you, we'll meet in the next video, okay, with a new module.